Good morning, everyone. Oh, nice timing on that hello. So, good morning, everyone. Welcome to today's lecture. Today, we're going to go over, we're going to briefly touch on abstract classes again, inheritance, and then interfaces. So, the concept has been introduced to you last week already and has been covered. So, in order to not confuse you too much for Thursday, I'm going to keep it light today. So, today, we're going to go over more of a guided discussion on an abstract class, inheritance, and an interface, and a potential use of it. But before we start with that, let's go into our Did You Know? So the first thing I want to find out from you guys is how many of you, guys and girls, how many of you actually read your terms and conditions? And how many of you use iTunes? iTunes has a service that is useful to use, not the application itself, but it comes with some useful services. So, have you even read the terms and conditions for iTunes? Because there's an interesting condition in their terms and conditions. By agreeing to their terms and conditions, you agree to not design, develop, or manufacture missiles, nuclear, chemical, or biological weapons. Yes, indeed. It is interesting. So by accepting their terms and conditions, you are not allowed to, I almost said create fun things, but you're not allowed to do devious, diabolical schemes, I guess. And yes, Mr. Levin, I do agree with you there. Companies do make their terms and conditions a bit more legal jargon heavy, so that the average consumer don't always understand or doesn't always understand what's being said. But if you read the terms and conditions from start to finish, they actually do include snippets that makes it a bit easier to read. But unfortunately, because of the size of the documents, not everybody reads the entire thing, and some of the statements are so ambiguous. You're never sure about where to use this. For instance, this specific terms and conditions comes from the export of products. If I remember correctly, it comes from the export of products section inside the terms and conditions on page 5. If you want to check up, so the link is down there, so you can actually see that it is there. If you don't trust me, but yes, you agree to not create nuclear missiles or chemical or biological weapons. All right, so jumping into today. So I've got an example for you. We're going to talk about Robert's Car Dealership. And Robert's Car Dealership is a small company that sells vehicles. So Robert sells motor vehicles to individuals and companies. That makes it a nice, lucrative business for him. So Robert, as a technologically disabled person, has asked you to design a system for him to manage his sales for him. Now, by managing the sales, he just wants to keep track of the vehicles and then the owners that will be linked to the vehicles. But there's a catch here. So Robert informs you that the following information is crucial for his business to operate. So for a vehicle, you've got the VIN number, the brand name of the vehicle, the model of the vehicle, and then the date sold. Now, for the car, there is a maintenance plan linked to the car as well. And the maintenance plan only starts once the vehicle has been sold. So the date sold is the start of the maintenance plan, just something to keep in mind. And then the maintenance plan period. If you have to code it out, just keep a comment next to the field for you to indicate whether the units are going to be months or whether the units are going to be years. Generally, it's associated with months, unless you actually want to explain the contractual obligations of a contract where you've got a year, 12-month cycle with your 15, I think it's 15,000 kilometers service plan. So regardless of that, but the idea here is when you do a integer value in terms of a maintenance plan, well, applying to this specific scenario, is you want to make sure that you ensure that the next person to maintain the software also knows the units that are being used. Because in software, they don't always describe the units when they use the variables, and that can sometimes be a bit difficult to maintain afterwards. So once a vehicle has been sold, Robert also wants to know who owns the vehicle, but does not want to keep track of the buyer. So Robert is only interested in the cars. He only cares about the cars, and he doesn't care about the users. Well, to a certain extent, he doesn't care about the users. He doesn't want to create a database of the users. He just wants to keep track of the car and then be able to find out who the owner of the car is. So that's the key point here. So the first thing we want to do is we want to create our base class. So in this instance, we've got our description for a vehicle, which is a VIN number, a brand, a model, and a date sold. So you can see I am using the PDF and not the PowerPoint, so you'll see that there is actually a notation issue here. Those are supposed to be colons, not as. So sorry, I forgot to convert it into PDF before starting this. I'll just make sure the correct one is uploaded to you after this. So you've got the base class vehicle. So you've got your 4 instance variables, and then you've got your constructors, your property methods, and your methods associated with this class. So here's a question for you. Is vehicle just a base class, or is vehicle supposed to be an abstract class? Now, ignoring the title at the top left-hand corner that says abstract base class, why would vehicle be associated with a abstract class instead of being a class that will be instantiated itself? Why would you consider vehicle a abstract class instead of just using it as a class that can be that you can create an object of this class? What would the reason for that be? It is the case that most of the times the base class is an abstract class, but it also depends on your implementation of that class or that program. So it depends on how you envision the use of that specific class. All right, so you've got different types of vehicles. That is correct. That's one option. You've got different vehicles have different functionalities and features. That is correct. We want derived classes to follow the standard all cars be sold should follow this template. Yes, that is absolutely correct. You want to establish a template, but there's another reason, and you're all touching on it, is the fact that if you look at the start, it says Robert informs you that the following information is crucial for his business to operate. And the description of a vehicle is so abstract in nature, in itself, that it tends to be information only almost. It's a template. That's actually a very nice way to explain it, but it's a template that's being used that should be implemented on the following classes that inherit from it. Now, in this case, no, I'm not implementing any functions in this case. That's why I'm leaving it empty. So if there are functions, it would be there as well. But now, with the base class in mind, you can expand on that. You've got the base implementation. You've got the template of what you want to do going forward. But I do have a catch for you. There's a catch coming. So the car would inherit from vehicle. So you've got the maintenance plan that's being added to a vehicle. And originally, I slightly modified it, and that's why maintenance plan is in car and not in vehicle. I included trucks as well, but the lecture became a bit long when I included that example. So there was a service included here, a service plan, because a maintenance plan and a service plan are two different things, essentially, if you look at it contractually. But if you look in terms of the information being extracted, vehicle has the information required for all vehicles, whether it is a bike, a car, a boat, potentially a plane. I know a plane has a bit more information, but you can derive vehicle and add more information to that. So it's not just relevant for Robert. You can potentially use this, package it, and reuse it somewhere else as well. So that template becomes now a established template that you can use somewhere else as well. But essentially, it is a stepping stone into what's going to come. Yes, I'm getting to that. So there is a reason why the base class doesn't include a vehicle owner. Now, Robert purchases these vehicles from the factory, the manufacturer, and he gets the vehicles, and he will potentially establish a vehicle. If you want inventory, you can establish a vehicle, add the information there, but that car being on the lot hasn't been sold yet. So that car doesn't have a owner yet. So depending on how you implement your classes as well, that information is going to be empty. So you can have it as car. You can have a prescribed maintenance plan with the specific car, but with no sold date yet. That maintenance plan hasn't started, but you have the vehicle. It's been established. That object has been created, and that object is standing on the lot ready to be sold. But now we want to add the owner. Let's say this car is being sold. What do I add? Do I now add the owner's details to car? Do I code it into the car class that inherits from vehicle? Okay, so we've got one person saying yes. Anyone else? All right, so I'm going to tell you no. Because keep in mind, Robert doesn't really care about the owners. He cares about his cars. So he's got a class for his cars, which is correct. So he can manage his cars that are not sold yet, and if the car is not sold, he doesn't care about the owners, because there is no owner. He is the owner, essentially. But now we want to add the owner's detail to the car. But we have this inheritance already. We've got car, it's been established. There is a maintenance plan. Under normal circumstances, I would say yes, we can use composition. But keep in mind, Robert doesn't want to keep track of the users. So if you create a class of a individual or a business now, you're doing exactly what he does not want. He doesn't want to track the user specifically. Because if you do composition, let's say you track the owners, then you will track the cars that the owners buy. So you would have a person, an individual, or a business class, and then you'll have an array of cars inside that class, and every time you buy a vehicle, it will be added to that array. That way, you're tracking the user and not the car. Now with Robert wants to track the cars, but he wants to know who's the owner of the car as well. So that indicates to you that the owner's detail somehow needs to be linked to the car, and the car not to the owner. But because he doesn't want to keep track of the owners, establish a database of the owners, essentially, it means you don't create a class for that specific owner. So how else can we do this? He doesn't want to keep track of the owner of the individual, the business, but he wants to be able to keep track of the car. Yes? Yes, that is exactly what I'm getting to, is an interface. Now, how do we implement an interface here? So essentially, you've got an option. Do we create a class for an individual or a business, which means you'll have your individual class and your business class that will have their own instance variables, their own constructors, their property methods, and their methods? But this is not what Robert wants. this is also not possible. Not only is it not allowed, Robert doesn't want this, what we've been talking about now. Why is it not allowed? Why can't you do this? Let's see if you can tell me. Why can't you do this? Specifically in VB now. Essentially Java as well, and C#. Well, you don't want to do it in C#, but that is correct. Multiple parents inheritance. So the problem here is we would like to have more information, but multiple inheritance is not allowed. So there is a sneaky way around this. Interfaces. So keep in mind that a class in itself has an instance variable, has the constructor, has the property methods, have methods. And it's basically computational code that's already implemented, or that is implemented, that can be used when it is inherited. An interface is a contract. It's a promise that you have. It's like a to-do list. It's like a to-do list. And this to-do list is things that you want to implement. It's like a checklist. These are the things that need to be there. We've got a question. So we make an interface for our derived class, not our base class. That is correct. Keep in mind that the base class itself tracks vehicle information. The derived class from our original base class keeps track of the car. So if the car is not sold, we don't want that empty information for a client or for a business or an individual, because then you're just wasting space. And then from there, we derive that again. Now, here's the catch. Let's say you change the specification of the car, you change the functionality of the car, you add features to the car. Where do you change that code? Because if you think about it, our two child classes now, personal car and company car. Only addition to those classes is the fact that we've got the promise that we have an individual's information, the personal car, and we've got the business information, the company car. But what's the benefit of this? You can see the benefit here. Because you're probably sitting there and thinking, well, I can just make personal car, and instead of having an interface, just put that information inside personal car already. Why do I need the interface itself? Essentially, it's not enforcing a standard. There's a benefit here. Like, we'll get to that question in a moment, but we can see the benefit. Let's talk specifically about personal car now. Personal car has the promise that it's going to implement a instance variable for name, ID, and contact. Essentially, the information of the owner of that vehicle will now be in that class. We've got the promise that it's going to be there. Why not just add that information into personal car directly? No, that's not the benefit. Modularity is one thing, but not the idea here. Let me put it this way. You've got one car, you've got a description of a car. What if he expands his business to include trucks, to include planes, to include boats? Every time he adds a new feature or function, or let's say he expands his business into a new section, He already has that checklist there. I individual and I business is there. It's been established. You now know exactly what you need for the derived classes if you're deriving either from vehicle or from car. But there's an additional benefit. Other than the checklist to establish that the information that you need for a specific category, I'm going to say category, but the information that you need to be implemented, other than having that checklist and not having to, every time you code a class, remember what needs to be there, what is the additional benefit here? Consider what functionalities you'll add to personal car. What additional functions are you going to put inside personal car that's not in car already? Because car in itself is everything with that specific car. The only difference between car and personal car and company car is essentially the owner's information that's just being attached to the car. What's the benefit? Think about it computationally. You're close. So for those watching the recording, the comment is we don't instantiate individual class, but rather an interface. So limit what functionality personal car can inherit based on the interface. You're very close. It's just your wording there. Then we've got a second comment, convenience, not having to add that information for every derived vehicle class. All right, so think about it like this. So the previous comment is you limit what functionality personal car can inherit based on the interface. That's not the idea specifically. The idea here is that if you want to add functionality, you add functionality to the car class and personal class will have it automatically. Because it's a derived class, it inherits all the functions, all the instance variables, all the constructors, all the property methods. Everything is already there and established. The moment you need to make a change, you don't have to change it inside personal car and company car and car. You only change it in car, and that functionality, that additional feature, will be there for the rest of the inherited classes. I mean, for the rest of the children classes. So the amount of change you have to implement gets minimized as well. Now, there is some aspect of redundancy here because with the interface, it's a promise that you're going to be implementing something. So essentially, if you see an interface class, you're already associating the fact that you'll have some small aspect of redundancy, of information being duplicated somewhere, or code kind of being duplicated somewhere. But in this case, it's because of that promise to implement certain things, that checklist we want to establish, that makes it useful. Now, in a first year aspect, an interface to you right now is you're gonna look at it and be like, but it's useless. We can just implement it directly into the, no issues. I can still inherit, and there's still no issues. But I can promise you, when you get to your third year and you start thinking about actual promises that you need to keep inside your code, establishing a framework, creating the interface, establishing that checklist of what needs to be there, you'll be happy that you used interface instead of just rewriting classes continuously. So the change is not made in the interface. No, the change is not made in the interface. The change is made in the base class of the derived class. Yes, classes can implement multiple interfaces. So an interface is one way to get around that small issue of not being able to do multiple inheritance. An interface, you can implement multiple interfaces. So essentially, you can establish functional comparisons in interfaces and have one class implement multiple interfaces if you want. It's one of the ways they use to get around the fact that you can't do multiple inheritance, is they do multiple implementations of interfaces. You'll see that a bit more next year in your second year as well. So it's an additional benefit as well. So interface has its own class and must be created once. So an interface it's just a checklist. So an interface lists the property methods that you will have and the methods that you will have with potentially the parameters, but no computational code. An interface does not contain computational code. An interface also does not contain any instance variables. That's why you'll see that in the slide, I use the term a property signature. It's one of the terms used within interface. It's a signature. It's something that's going to be there. So when you implement it, it will create those property methods for you, but you still have to create the instance variables that link to those property methods. Same thing with the methods that you would include. The methods, as with a must inherit, the methods that you create in an interface are a computational list. There's no code linked to it. It's just the name of the function, the name of the method, the parameter list, and the return type. And that's all. And then when you implement the interface, it will create that blank method for you where you will create the functionality or the computational code for it. Computational code is the code. It's the code that actually does something. Properties for derived class only. Can you maybe just expand on that? Are you referring to the property method or the property signature I'm talking about in an interface? We're talking about the implemented. All right. So maybe I should just show you an interface. If I can find my cursor. So let's open up Visual Studios. Let's see. So inside the car class, we would have two instance variables, personal car and company car, of which personal car will implement individual, and company car implements yes. So basically, it increases the efficiency of your code, not having to run through the owner's info if the vehicle has not been sold. That is correct. It improves the efficiency slightly, but it's not 100% the idea. Well, not 100% the idea behind it. Just call this lecture 12. Oh yes, I almost forgot about that. Right. So while I'm loading up Visual Studios, the group allocations have been completed now. So you'll see if you go onto Eve, you'll see that there is a PDF that we've uploaded, or that Mr. Cottrell have uploaded for you. You can search for your student number, and then you'll also see the group that you have been allocated. So for teams that are 3 to 4 people in the group, we left you as is. So you can be the 3 or the 4 members. Teams of 2, we've merged you together. So if you had a team of 2, you will merge with another team of 2. And if you didn't have a team already, we allocated you to a team, but we tried to match students of similar submission rate or frequency. excluding last week's submission, because last week's submission was not the best, but I assume it's because you had a test on Friday and a test on Saturday as well. So I don't specifically blame you for not uploading potentially. I do, but I can understand. So we tried to match individuals that were not in teams with other people with the same frequency of submit, make it a bit more fair. So you know it's people that actually do submit. I do encourage you to communicate with your team members. Make sure you have a channel of communication for when this project is now being released. We'll probably release it. I think we release it the Friday before recess, if I'm not mistaken. But we'll tell you exactly when we release it. So just go and make sure that you are in a group. If you're not in a group, please just email us. I think email us and post it in Discord, because there is an issue with the emails at the moment, and we'll double check that. And then another reminder is, please remember you're writing a test on Thursday morning, and you can't be late for that. All right. Okay. Sorry about that. My connection cut out there for a second.
Okay. Afternoon, ladies and gentlemen. See, Ms. van der Vesthuizen, some having some internet problems, so he's just asked me to jump in for a few seconds. Just answering some of the questions I'm seeing in the group, in the chat. If your team suddenly reduced from 4 to 3 people, that's fine. I only work with people that are registered, so if someone's deregistered, it'll automatically be adjusted. But let me know if it hasn't been adjusted, and let me contact that person just to verify the situation. Can we turn on compile options for the whole project instead of for every class? No, you'll do it for each class, as discussed for the reasons we're on Discord as well. Remember, the purpose of the option statements is for you to be able to remember the purpose of them and why you're doing them. Remember, the option statements aren't there to force you or force the program to do certain things. It's to force you as a developer to do certain things. Will the test be run over Blackboard? Hell no. The test will be done on Eve and submitted on Eve. We will upload a guideline onto Eve on how to do it within the week. So before the test is, we'll upload guidelines that you can read for and get prepared for. Where do you see group allocations? Again, go to Eve, go to underneath lecture notes. There'll be a PDF called group allocations, and just search your student number. Your group number will be next to that. And then you can see the people that are allocated to the same group as you. I've ordered the student numbers and group allocations by group, so you'll see 4 names and then a group, 4 names and student numbers in a group. To contact your group members, you can use Discord or you can use the student email account. Tomorrow's TUTS will be a revision, yes. No new content. Tomorrow's TUTS will be a revision and Q&A session. Okay. There will be buffer time, yes. I know for the students repeating the course, this is something new that you're doing online. We will upload guidelines and how it all works with the buffer time, etc. There will be buffer time for uploading, etc. That'll all be inside the guidelines. But ladies and gentlemen, the buffer time is not for you to have extra time to write. It is there simply for you to upload the test. So we'll give you enough time to do the test, and then you have a bit of extra time to upload the test onto Eve. We will not use Blackboard whatsoever for the test. The only reason we're using Blackboard is for the Colab Ultra feature we're using right now, and the fact that we can upload tutorials to Eve, to Blackboard, save on space. Okay. I don't know if Ms. van der Westhuizen is ready to go again. Okay, while he's sorting out on his side. Any other questions, ladies and gentlemen? How do you approach this week's practical? It's an open-ended practical, so there's no real restrictions on it. Let me just download the prac again. You define your own class. We gave you a base class and you define the rest for it. Okay. How many pracs count for your PCM? We'd normally take the best 8 or 9 practicals, so we always take into consideration one practical as a bugger up. Yeah, here Ms. van der Westhuizen is back.
Yeah, sorry, I almost burnt the place down.
It's never good. I'll hand over to you.
Okay. Let's just check the last questions coming in. So what's the difference between an abstract class and a base class? All right. So an abstract class is linked with the keyword must inherit. Can the yeah. Okay, so an abstract class is linked with the keyword must inherit, which indicates that it's not a class that's going to be used to create an object. It's a class that's going to basically be the template for the derived classes. A base class is a class that can be instantiated, so it can create an object. So as you have with car, let's just open up the slides again. As you have here with car, so car is a derived class. So it has an instance variable that has the constructor, property methods, and methods. But car is also a base class for personal car. So that information or that instantiation can be established either for car or for personal car. So you can create an object of car and you can create an object of personal car, but you can't create an object of vehicle because vehicle will have that must inherit description, and it must be inherited. But you also have some functionality. So with a must inherit, you can also have the must override description for certain functions that dictate that a function must be overwritten or overwrote. So company car and personal car are both derived classes. So they inherit from car. So car becomes their base class, where vehicle is car's base class. Yes. So only car inherits from vehicle, because remember, vehicle, the information in vehicle is now inside car as well, because car inherits from vehicle, which means that car is a vehicle. That information is there. It's just inside the base class. The functionality inside car will link to the vehicle. Now, once you inherit from car, you are now establishing so personal car is still a car. It still inherits from vehicle. So you have the information that's in vehicle, but you also have the information that is in car now. So the derived classes should also have property methods in the UML diagram and actual code. Yes. So if you have, let's put it this way. If you don't have any instance variables that you're adding to the derived class, then you don't need to add any additional property methods, because the property methods will be linked to the instance variables inside that specific class. So you can have an instance where you have no additional instance variables, but you have additional functionality linked to a class itself. So there is that option. When you add, let me just go to that page. When you add instance variables, you automatically add the property methods. But if you don't add instance variables, you don't need to add property methods, because the property methods for the instance variables inside the inherited class will be inside the inherited class itself, unless you must override it. But I don't think you do. I've never seen an implementation where you must override a property method. How many classes do we have now? So currently on the slide in front of you, you will have 4 classes. You've got a vehicle class, you've got a car class, you've got a personal car class, and a company car class, where vehicle is the base for car, and car is the base for personal and for company car. No, so car won't be must inherits, because car can be an object, which means we want to establish an object of car. That is now the car standing on the dealership lot. Vehicle is not something we want to establish an object, or we don't want to create an object of vehicle. So that is why it's an abstract class. It's a template. It's a format going to be used. Car is instantiated, and then personal car, once the car is sold, you can instantiate personal car and have that information inside there. So you've got the 4 classes and then the 2 interfaces. And to get to your question, no, car will not be a must inherit, because you want to implement car. You want to create an object of car. Right, I was going to do something before I almost went the place down. Oh yeah, interface. Do I have enough time left to show an interface? Let's actually see if they have an interface here for you. We've created it by scratch. No, okay, so they have an interface component for you. So you can just go interface. Let's do iBusiness. So you've got your public inheritance, public interface iBusiness and in interface. You'll have your property. What was it? Property name as string. Time is eaten by a dog. Well, in this case, time is eaten by a 3D printer that's set light. You've got reg number, string, printing fire. That's an idea. Contact as string. So there we have our interface. And what's the one thing you notice here? What is not inside the interface class, or inside this interface? No code. Yes, no code. Property methods. Not essentially property methods. It's more a signature of the property method. Because remember, there's no computation here, computational code. It's just a template. It's not even just a template, it's a promise of what's going to be there. So let's go and just quickly create a class so you can see how it's implemented. I have no minutes left essentially. All right, let's just add a class quickly. Let's just call it car. And then car implements I business. And you'll see there are the getters and setters created for you. But you still have to go and create the instance variables. So I will still have to go and create my private name, private reg number, and my private contact as string, and then obviously make sure I go and set them. So the interface is essentially is essentially just a what is going to be there. So the moment you implement it, it already puts the empty spaces there for you, the empty signature of that class. So for your checklist, they are there. You just need to go and fix them, or not fix them, but now add the computational code to it, the things that will actually do something. Now, one of the benefits of the Microsoft implementation of interfaces, it adds this throws no not implemented exception. So if you forget to add code, it won't break the program. It will just throw the exception for you. So the exception will just tell you you haven't implemented the computational code for it yet. And we'll get to exception handling later on this week or next week. I might push it over to next week. All right. Why do we use the property keyword? So the property keyword is to indicate that you'll have an instance variable called name. But because interface doesn't have any computational code, it doesn't have any instance variables. It just has a signature of what's going to be there. Now, if you have a property method name, then that means you'll have an instance variable also similarly called name. And then the same for registration number and the same for contact. That information will be there. It's, like I said, it's a checklist of information that's going to be present. So when you have multiple categories of vehicles, you've got boats, planes, cars, bikes, and you have one template, you've got this one interface of business or personal information, then you can implement that and you'll know everything is there. No. So if you want functions or methods, you would call it something. You'll have a type. And then that would be, it's a promise of what's going to be there. There's no computational code to it. So when you go to your car, you'll see that it gives me an issue now. So if I just remove all of this quickly, we'll re-implement it. If we implement it, you'll see that it adds that empty function for me already. So the parameter list is already there, the return type is already there, but it also tells me it's implemented from iBusiness. So it tells me it comes from the interface, and then it adds that throw new not implemented exception that indicates that it has been used. So there are methods, but there's no there's no computational code inside an interface. It's just a blank statement of you will have this, you will have this, you will have this. Now, the one thing you will notice, there's no modifiers, there's no private, there's no protected, there's no public, and when implemented, they all implement as public, which makes it convenient for us. So everything inside an interface is public. All right, but I'm going over time now. I'm sure some of you might have a class. We will maybe touch on, well, we won't touch on interfaces tomorrow in the tutorials. So during the tutorials tomorrow, we'll be doing some revision by going over one or two of the past paper questions. And please don't forget about your semester test on Thursday. I think Thursday morning. Yeah, and I think that's all day. So if you have any questions, I'll stick around for a while. I'm just going to stop the recording here. So for those that are coming to our tutorials, good on you. And for those that are not coming to tutorials, I suggest you do come to this week's tutorial. And for those that never do the practical beforehand, I highly recommend you have a look at your practical beforehand. There might be some benefit to spending some time on your practical this week. It's all I'm willing to say on that. Other than that, I'll see you guys tomorrow in the tutorial, or I'll see you Wednesday morning for your lecture. Enjoy the rest of your day.